Today we'll be talking about the distance formula. It's the way that we can find out the distance between two ordered pairs. Really, we're saying the distance between these two ordered pairs when they're graphed on a coordinate plane. So I'll just give a really rough sketch of what we're talking about. So 5, -1 would be somewhere around like here, and then 3, 7 would be maybe up here. So they're saying, how could we figure out the distance between those two? Because it's not just a straight vertical or horizontal line where we could just, count the number of blocks. So we've got to use this formula. So the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So and what we're really finding is x2 minus x1 says, how far apart are the x values? So in this case, it's 3 and 5. So for whatever reason, they made it so you do the second one first. So this is our x1, because it's the x in the first term. That's all the 1 means, is it's coming from the first point. This is our x2. And again, the 2 just means it's coming from the second point. Then we have y1, because it's the y coming from the first point. And y2, because it's the y coming from the second point. So we subtract the x's first, x2 minus x1, then we square them. So they put in 3 minus 5. 3 minus 5 is -2. -2 squared is +4, because a -2 times a -2 is +4, because squared means times itself. So it's a negative times a negative, which will give you a positive. Then it's saying find the distance between the two y values. So y2 is 7 minus -1. So I just put a plus here because minus and negative is the same thing as plus and positive. 7 plus 1 is 8. 8 squared is 64. Then you add 4 and 64 together, get 68. And then in the calculator, you can take the square root of that, and we'll round to 2 decimal places for this. So the distance between these 2 points is 8.25 units. So let's practice these. Now I'm not going to label x1 and y1 all the time, but I think it'd be helpful the first few times for me to do that, for you to make sure you know what is going where. So I do the square root of y2 minus y1 squared plus, I just did the y's first. Shoot, I'm sorry. It actually doesn't matter whether you do x or y's first, but I'll make sure to do the x's first and all the others. So I need to do the x's, 5 minus 1. Okay, so let me just explain what I accidentally did. I accidentally did the y's here and the x's here. That's not going to change our answer because we're adding. So just think about this one. If I had done this one in reverse, I would have just gotten 64 plus 4 instead of 4 plus 64. So you'll still get the same number either way. But I'll make sure I follow the pattern and do x's first from here on. So 7 minus 3 is 4. 4 squared is 16. 5 minus 1 is also 4. 4 squared is 16. So we get the square root of 32. And when you plug that in the calculator, it is approximately 5.66. Okay, remember, Mr. Lin, it's x's first. So on this one, it's -4 minus -8. Minus and -8 is the same as plus 8. Then it's -10 minus -9, which is the same as plus 9. -4 plus 8 is 4. 4 squared is 16. -10 plus 1 is -1. -1 squared is +1. So we get the square root of 17. And when you type that in your calculator, it's about 4.12. And the reason I'm using these squiggly lines and saying about is we are rounding it off. So square root of 17 is the exact answer, But this is just an approximation of the answer since we're rounding and cutting it off. Okay, number 3, x1, y1, x2, y2. So we do the x's first, 1 minus 10 squared plus negative 4 minus 6 squared. 1 minus 10 is negative 9. Negative 9 squared is 81. Negative 4 minus 6 is negative 10. Negative 10 squared is positive 100. So we get the square root of 181, which is approximately 13.45. Okay, number 4. We do x2, which is 8, minus x1, which is 3. Sorry, that's a 3. Then square it. Plus y2, which is 2, minus y1, which is also 2, and then square it. 8 minus 3 is 5. 5 squared is 25. 2 minus 2 is 0. 0 squared is 0. So we get the square root of 25, and the answer is 5. That one comes out even. Comes out as a whole number. Okay, number 5. I'd actually encourage you to try the rest on this page on your own, and then you can check the answers. So I would encourage you to pause and try 5 through 10 on your own, then check back and see if you got the correct answers. I'm just going to write the correct answers and show the work, but I'm going to go through them pretty quickly. So number 5, we do negative 1 minus 9 squared plus 8 minus negative 3, which is plus 3 squared. When you simplify all that, you'll get the square root of 221, and that's approximately 14.87. Now, if you didn't get that, I encourage you to pause it and look through where I put numbers and why, and check my work in your calculator so you can practice. But I'm just going to keep rolling through so you can see examples. Number 6, we do 0 minus 10 squared plus 4 minus 0 squared. That gives us the square root of 116, which is about 10.77. Seven, we get the square root of 6 minus negative 7, which is plus 7 squared, plus 9 minus negative 2, which is 9 plus 2 squared. And when that's all simplified inside the radical, we get the square root of 290, and that is approximately 17.03. Number 8, we do the square root of 8 minus a negative 6, which is plus 6, plus the square root of negative 3 minus 5, then square it. When you simplify that, you'll get the square root of 260, which is approximately 16.12. Number 9, we get the square root of x2 minus x1, so minus a negative 5 is really plus. Sorry, I'm using y's. Let me correct that. I don't know why I keep doing that. So x2 is negative 9 minus x1, so that's negative 5 squared, plus y2 negative 4 minus a negative 6 is plus 6, and we square it. Okay, just making sure I'm on the right track here. Okay, yeah. When you simplify all that, you get the square root of 20, and that is approximately 4.47. Okay, last one on this side of the page, we get the square root of negative 7 minus 2 squared plus 1 minus 0 squared, and that is the square root of 82, which is approximately 9.06. Okay, there's just two on the back, but they're the exact same process. But I just wanted to show you how this can be applied in other ways. So first of all, it says classify triangle JKL with vertices 3, 0, 1, -3, and negative 2, 4 by its sides. Then find the perimeter to its nearest tenth. Okay, so I'm just giving a very rough sketch again. 3, 0 would be about here. 1, -3 would be about here. -2, 4 would be about there. So we're trying to find the perimeter of this triangle. This is J, K, and L. Now we're going to need to figure out the length of each one of those sides. So we need to find out the length of JK. We need to find the length of KL and the length of LJ to figure out what the total perimeter is. Because once we find out the length of those sides, we can then add all three of them together. So for JK, I'm going to zoom out a little bit so we have a little more room. For JK, we'll use these 2 points to do the formula. So 1 minus 0 squared, x2, 1 minus 3 squared, my fault. 1 minus 3 plus -3 minus 0. Okay, that gives us the square root of 13, which is approximately, calculator out, sorry. Square root of 13. I know it's going to be between 3 and 4, but that's about all I know. Okay, sorry for my delay. I should have had this out already. Square root of 13, 3.605. We're just right to the nearest tenth. I'm just trying to put some extra here so that when I add them together, I should get the correct tenth. Okay, so we've got this side covered. Now we'll do KL. So KL means we use these 2 points. So I do the square root of -2 minus 1 squared plus 4 minus -3 or 4 plus 3 squared. And when you simplify that, it becomes the square root of 58. And the square root of 58 is approximately 7.615. Finally, we'll do LJ. So we've gotten this side done and this side done, so just that third side, and then we'll have business. So this is using the first and the last points. So our x's are -2 and 3, so I do -2 minus 3 squared plus 4 minus 0 squared. When you simplify all that, you get the square root of 41. And the square root of 41 is 6.403. So we need to add these three numbers together because the perimeter is the length of all three sides put together. And when you combine them, when you round to the nearest tenth, you should get 17.6 units. We're just saying units because they didn't tell us inches or meters or miles or anything like that. So just to show we didn't forget there are units, we put units. Now, I know that's a pretty long one, but it can be very helpful for engineers and architects who are trying to figure out, okay, if I design something this way, how much material do I need? Okay, last one, and this one is not as long. So the Yeager family is visiting Washington, D.C. One unit on the coordinate system on their map is 0.1 miles. Find the distance between the Department of Defense at -29 and the Madison Building at 3-3. So we need to find the distance between these 2 points. So we'll start with that. The distance equals x2 minus x1. So minus -2 is the same as +2. y2 minus y1. And we get 5 squared plus -12 squared, which gives us 25 plus 144. That gives us the square root of 169, which is exactly 13. Okay, but we want to look back at the problem to make sure we understand what we just found. We didn't find a distance yet. We just found how many blocks on the grid these two are apart. Because what the map says is each block on their coordinate grid is representative of 0.1 miles. So if one block is 0.1 miles, then we can multiply this by 0.1 to find out that the distance between those two buildings is 1.3 miles. Okay, last thing I want to talk about. How is the distance formula related to the Pythagorean theorem? So believe it or not, they're actually pretty much the same equation. Now this one has a little more work to it, but I'm going to try to show you how that's true. So let's say let's just try, I'll just make the point -1, -2. I'm not going to solve this, I'm just trying to give you an illustration. I'll give the point 3, 1. So we find the distance from there to there. However, when we do x2 minus x1, this part right here, we're finding the distance between the two x values. We're finding the distance between 3 and -1, which is the same as the horizontal distance from one point to the other. So this is our x2 minus x1. Because when we subtract them, that tells us how far apart are the two x values. Just like when we do y2 minus y1, it tells us the distance between the two y values. So we are actually finding the horizontal distance between the two and the vertical distance between the two. If you notice, by doing that, we've actually created a right triangle. This is the distance. This is the x2 minus x1 and the y2 minus y1. Okay, now when we had the Pythagorean theorem and called this a, b, and c, we knew the lengths of these sides were related by saying a squared plus b squared equals c squared. So really x2 minus x1 is our a, y2 minus y1 is our b, and then our hypotenuse length is our distance d. So let's try plugging this into the Pythagorean theorem. So we do x2 minus x1 squared plus y2 minus y1 squared. And that's equal to the hypotenuse, which is the distance squared. However, so this is really a squared plus b squared equals c squared. But we don't want to find out d squared, we want to find out d. So the way we solve that is we take the square root of both sides, and the square root of d squared is d, and the rest of this gets left inside the radical, giving us our distance formula. Believe it or not.